Dear students, in this session we will be discussing about renewable energy sources. As you all know, energy is a primary and most universal measure of all kinds of work by human beings and nature. Whatever happens in the world is only the expression of flow of energy in either of its form. Energy is very crucial in economic, social and industrial development. Energy consumption in the developing countries is increasing at a faster rate. As conventional energy sources are dwindling day by day, utilization of alternative energy sources is the only solution to meet the increasing demand. India has made rapid strides towards economic self-reliance over the last few years. The gap between energy demand and supply is widening day by day. The present mismatch between energy generation and consumption, depletion of sources of unconventional energy is serious in nature. Unless a long-term planning is done to handle these issues and commercially viable and environment-friendly alternative technologies are developed, it will spell doom. India, being one of the most populated countries, will be affected to the maximum. Presently, most of the petroleum products are imported and steady rise in the prices is affecting the Indian economy. Our country can step this financial drain only by self-sustainability in the energy sector. In this session, we shall be throwing light on major renewable energy sources available to get energy. The structure of the session will be like this. We will first talk about Indian power sector scenario. Then we will discuss about the types of energy sources, that is non-renewable as well as renewable. Benefits, then we will discuss benefits, characteristics and potential of renewable energy sources. Then we will discuss each renewable energy sources in brief, like wind energy, small hydropower, solar energy, biomass power, etc. And then we'll conclude the session. Now we will discuss about Indian power sector scenario. Now the power sector availability of our country, installed capacity of power as on 31st August 2009 is 1,52,148 megawatt. Here I shall briefly describe about the concept of measuring generating capacity. The power generation capacity is measured in megawatts. Students, it should not be confused with kilowatt hour, that is the energy, because power and energy are different. I can give you a simple hydraulic analogy. Say for example, a tank is full of 1000 liters. A tank capacity of tank is 1000 liters. So 1000 liter water can be stored in that tank. Suppose one tap is connected from the tank. So the water which the tap is supplying is the energy consumption, whereas the capacity of the tank denotes the capacity to hold water. Similarly, in power sectors also, when we are talking about installed capacity, it is counted in terms of megawatt, whereas in our daily terminology, we are energy consumption is being utilized in unit hours, kilowatt hours. Now about 1 lakh 50,000 megawatt capacity, installed capacity. On this plate you can see the breakup of that capacity, how this energy is coming, like thermal, hydro, nuclear and renewable. These are the major four sources of energy in our power in our country. You can see from this plate that thermal energy constitutes a major chunk of the total installed capacity, followed by hydro, renewable and then nuclear. Nuclear is still in a nascent stage. The projection of power requirement in our country is around 2,40,000 megawatt. So there is a huge difference between the availability and the requirement. This plate shows, the pie chart shows the visual description of the various power sources like thermal, hydro, nuclear, renewable. From this pie chart it will be more clear that thermal is a major portion which is contributing to the total installed capacity. In world over also the same trend is can be seen, and because the major source of energy is coal only, that is thermal power, followed by hydro and nuclear. This chart shows the graphical representation of the consumption and production of power in India. As you can see, the gap between consumption and production is increasing day by day. Now we will see what are the sources of energy. So there are two sources of energy, renewable and non-renewable. As the name suggests, non-renewable means these type of source of energy are exhaustible in nature. Means once they are used, they cannot be regenerated. The most common example of non-renewable energy sources are petroleum, natural gas, coal, and nuclear. Of this, petroleum and coal are the major sources as far as conventional non-renewable energy sources are concerned. There are certain unconventional non-renewable energy sources are also there, that is oil shale and natural gas hydrates. But mostly petroleum, natural gas and coal are used world over. Now we will see renewable energy sources. As the name suggests, these can be regenerated, renewed, and they are virtually inexhaustible. The types of renewable energy sources are solar. Solar again it constitutes solar photovoltaic and solar thermal power. Then wind energy, hydropower energy, biomass energy derived from biomass, ocean energy, geothermal energy, and waste to energy means the waste generated can be used to generate the energy. There are three primary sources of energy. The three independent primary sources providing energy to the earth are the sun, geothermal forces, and planetary motion in the solar system. The earth receives basic energy from sun. Then there are geothermal forces inside the crust of the earth which result in heating up of magma and rocks. That is also a source of energy. Another is planetary motion in the solar system, like gravitational pull of moons, which result in tides in on Earth. This is a represented. This plate shows renewable energy and non-renewable energy various sources of renewable energy and non-renewable energy. As you can see, there are two distinct entities, and our renewable energy is having wind, solar, geothermal, water, biomass. Now, why do we need alternative energy? As I was discussing, the availability of energy is increasing day by day, and our sources are limited. As we consume petroleum, a day will not come when we will be exhausting all the sources. So it is very necessary to search for alternatives right from this stage, because fossil fuel reserves are very limited. Population is also increasing. India's population is increasing, and energy, and with the population increase, requirement of energy is also increasing. So we have to meet that additional energy demand also. For that, we need to search for viable alternative solutions for energy requirement. India imports around 110 million tons crude annually. So a major chunk is being spent as foreign exchange towards meeting energy requirements. Moreover, 52% of households and villages, so many villages are unelectrified. So we have to search for alternatives so that maximum number of villages can be electrified in viable manner. We shall now come to the characteristics of renewable energy sources. The most important characteristic of renewable energy sources is that they are virtually inexhaustible. There is a continuous supply which we can realize. It has got a large inexhaustible source. For example, solar energy. It is intercepted by Earth at the rate of 1.8 into 10 raised to the power 11 megawatt. Another benefit is it is a clean source of energy. That it is very environmental friendly. Then large collection areas, but at the same time, these renewable energies are also have high capital costs, and the major disadvantage is that its availability varies with time. For example, wind power. Wind may not be available at all the times, so it is highly cyclical in nature. Then there is a need for additional storage because, for example, if we are generating power by wind, then we need to store that power also, or evacuate that power and supply transmit that power over long distances to load centers. So these are the characteristics of renewable energy sources. Now, what are the benefits of renewable energy sources? The major benefit is that they are environmental friendly. By using the renewable energy sources, we will be reducing emissions of carbon dioxide and other pollutants. Then it leads to local and regional development because in rural areas particularly, it is not economically viable to supply grid electricity. So for that purpose, we need to have renewable energy there. It will also lead to local and regional development and economic and social development of that area. It also helps in creating local jobs locally. Then major advantage is that it leads to security of energy for a nation. These are the various power generation options which are in vogue, like centralized grid connected. This is the most popular way. Mostly in India it is employed, but it is restricted only to urban centers. Then another way is decentralized distributed generation isolated. It means that it will be isolated, this mode will be isolated from the main supply and it can be used as a separate system. Then cogeneration or trigeneration. What do we mean by cogeneration? Cogeneration means that we are using an industrial process to raise steam which can be used for process industry as well as to generate the power. And the fourth is demand side management. That is, by managing the loads, we are using less energy and that way we are helping in generation. This table shows the potential of renewable energy sources in India and status of installation, that is the potential which has been already harnessed. From this table it can be seen that the maximum potential is for wind power, and that is a sector where we have worked so much and we have realized 10,000 megawatt, around 10,000 megawatt potential has already been commissioned in India. Next is small hydropower that is up to 25 megawatt. There we are having we have commissioned 2430 megawatt. Then these are the various sources. This table shows what is the total potential from renewable energy sources in India is pegged at around 83,000 megawatt, of which we have commissioned only 14,000 megawatt as of now. It means still there is a huge potential to realize this renewable energy systems. By realizing this potential, we can meet almost 25% of our total installed capacity. Now we will come to various sources of, we will discuss various sources of renewable energy one by one. First we will start with wind energy because that is the area where maximum potential exists. India has done very good work in the field of wind energy and it ranks 5th in the world after Germany, USA, Denmark and UK. The wind energy potential in India has been estimated at 45,000 megawatt, of which 10,000 megawatt has been installed. Certain states in India, they have very high wind power potential like Tamil Nadu, Gujarat, Andhra Pradesh, Karnataka. So nowadays, rapid strides have been made in the technology of wind turbines also, and a single machine of up to 4.5 megawatt capacity is now available. And the average capacity factor of these wind turbines is around 14%. So, what is wind energy? Its basic principle of operation is very simple. The kinetic energy of wind is converted into mechanical energy, which in turn is used to generate power. So wind turbines are being used since times immemorial. Even olden days also, prehistorically these wind turbines were used to raise underground water. So this is not a new concept. This is a very old concept. Only thing is that certain technological changes have made it more economically viable, and it can be used on a large scale also. Like wind turbines, nowadays wind turbines are mounted on a tower to capture the most energy, because as the altitude increases, the wind speed also increases. So it would be advisable to put it on a certain height. So say at 30 meters height, this is the usual height at which wind towers, commercial wind towers are installed. 30 meters above ground, they can take advantage of the faster and less turbulent wind, because if we go higher up, then the turbulence of the wind will increase, which is not a conducive thing. Then turbines catch the wind's energy with the propeller like blades. And usually 2 or 3 blades are mounted on a shaft to form a rotor. This concept can be more in a better way, it can be explained graphically also. And this chart, this is a cross-sectional view of a wind turbine showing various parts. You can see from this chart that the major component of a wind turbine is the rotor. The rotor has got 2 or 3 blades. Then the shaft of the rotor is connected to a gearbox. That gearbox is in turn is connected to the generator, which when the blade turns, then it moves the generator also, and it generates power. Other things like controller on yaw drive, etc. are also included to control the speed of the wind turbine. This map shows the wind. This is a wind resource map of India. This map shows the existing potential of wind energy across different states. It can be seen from this map that maximum potential is there in Tamil Nadu, Maharashtra, Karnataka, coastal parts of Gujarat, and even desert area of Rajasthan. This is a plate showing a wind farm where a number of wind generators are commissioned and they are connected. This is a standalone wind energy generator. You can see from the foreground, in the foreground there is a tree, so that you can have an idea of the height of the wind tower at which it is installed. So we were talking about the components of the wind turbine, and there are various components like anemometer. It measures, basically it measures the wind speed and transmits wind speed data to the controller. Then blades. Most turbines have either 2 or 3 blades. Wind blowing out the blades causes the blades to lift and rotate. Brake. A disc brake which can be applied mechanically, electrically, or hydraulically to stop the rotor in emergencies. Then there is controller. This controller starts up the machine at wind speeds of about 8 to 16 miles per hour and shuts off the machine at about high speeds to prevent damage to the rotor. Gearbox. Basically what happens when the wind blows, drives the rotor, it moves at a very small slow speed. So that speed is converted to a high speed through this gearbox. Then this generator, it is usually an induction generator that produces 50 hertz frequency AC electricity, and there is high speed shaft which drives the generator. These are the various components of wind turbine. The towers are made from tubular steel, concrete or steel lattice. It can be of any material. Because wind speed increases with height, taller towers enable turbines to capture more energy and generate more electricity. What are the advantages of wind energy? It is a clean fuel source. No pollution is involved because you are only utilizing the natural wind which is available. It is inexhaustible. It can never, there is no dearth of wind. then it is one of the lowest price renewable energy technologies. We'll later on we'll compare the capital and running cost of all the sources of energy. In that chapter we will see in detail what are the pricing. But it is this wind energy is one of the lowest price renewable energy, and that is the reason it has been developed in India at a considerable rate, and it benefits the economy in rural areas. Now, what are the disadvantages? Let us see the disadvantages also. As compared to fossil fuel generators and conventional power plants, it has got a higher initial investment. A major disadvantage is that wind is intermittent and it is very unpredictable. So, wind energy cannot be stored. It cannot be stored. And good wind sites are often located in remote locations far from cities where the electricity is needed. So a lot of cost is involved in evacuating that power generated from the wind generator and transmitting it over long distances to the load centers. Another disadvantage is that it may compete with other uses for the land, because the requirement of land is huge for establishing wind power plants. So it may compete with other uses for land, for example farmlands or other uses also. Now we will come to small hydropower. This is an exhibit showing a small hydropower. As you can see from this photograph, that a pipeline sort of structure has been brought from the top of the hill, and it has been brought this water. It is transmitting water at high velocity, which is driving a turbine, and the power is generated. Usually, the water is fed from stream, canal to the turbine by closed pipe. This closed pipe, which we saw in the photograph, is called penstock. This is the technical name for it, penstock. So, the source of water is usually existing river stream, from where the water is brought in this penstock. This water then rotates the turbine at high velocity for electricity generation. There is a formula that how much power can be generated from a small hydropower plant. This formula is given by power in kilowatts generated is equal to 9.81 into discharge, that is the flow of water, how much water is flowing, and head from what height this water is coming, and what is the efficiency of the turbine. This formula gives the power generated. Advantages of small hydropower. This small hydropower, it has got non-consumptive use of water. It means that actually we are not utilizing this water, we are just using the kinetic energy of this water to generate power. It also does not require a very large capital investment, and it has got a very short gestation period ranging from 6 to 24 months. So in a matter of around 2 years it can be commissioned. It has low operation cost also, and not much technical knowledge required. Unmanned power stations are also possible in this case. It can be connected with electricity grid, and it can act as a catalyst in promoting socio-economic changes in remote areas. It is definitely more eco-friendly than as compared to conventional hydropowers, because a lot of environmental concerns are being raised for conventional hydropowers. So these small hydropowers are a very good substitute to the conventional hydropower. And small hydropower is significant for off-grid, rural, and particularly in mountain areas, hill areas, where a lot of scope exists for this small hydropower. Now we'll see how these small hydropower plants are classified. Classification based on the capacity. Various countries adopt various systems for classifying these small hydropower plants, but in India we have classified it into three parts. One class is micro, when the station capacity is up to 100 kilowatt. SHP, whose capacity is up to 100 kilowatt, is known as micro power plant, micro small hydropower. Then comes mini. This capacity ranges from 101 kilowatt to 2000 kilowatt, that is 2 megawatt. 1 megawatt is equal to 1000 kilowatt. And the next comes small hydropower. Its capacity ranges from 2 megawatt to 25 megawatt. Above 25 megawatt, all the power projects in the sector are classified under hydropower. Type of schemes, how these small hydropower projects are constructed. There are three systems actually in this. One is run-off river based. Run-off river is the flow of water is utilized to generate the power. So no storage is involved, and the output is of course subjected to instantaneous flow of river. So if the flow is less, then the power generated will be less. And reliability of discharge is very much necessary to be established, because if there is no reliability, then plant factor will go down. Second classification is canal based. It utilizes the fall and flow in the canals. When we are constructing canals for irrigation purpose, it follows the natural topography of the area, and when there is a natural gradient then in the canals, this gradient is utilized to generate power. It can be planned also while constructing the main canal or in bypass canal. So the drops in the natural gradient of the canal is used for generating power. Then the third scheme comprises of dam based small hydropowers, in which dam tow schemes are most common in India. Here water stored during monsoon is utilized for power generation. Cost aspects of small hydropower. The parameters affecting costs are: what are the physical sizes of civil works and electromechanical equipment, what are the construction aspects, and operating costs. These are the three components of project cost. The unit cost of hydro schemes is inversely proportional to the head. That is, higher the head, lesser the cost. And per kilowatt cost may be ranging from say 40,000 rupees to 90,000 rupees depending upon the layout, and it is very location specific. If we compare small hydro with other renewables, it is the highest density renewable energy source against widely spread and thinly distributed solar energy, biomass, wind resource, etc. And its cost of generation is also cheapest among renewables. Small efficiency of small hydro plants are highest among renewables as compared to wind energy or say solar energy. The efficiencies are comparatively higher. This table shows the state-wise sites identified for development of small hydro projects. We can see from this site that total capacity of around 8,000 megawatt has been installed. In India, there is huge potential for hydropower projects, and very less has been harnessed so far. Particularly in hilly and mountain regions, Himalayan regions, in states like Himachal Pradesh, Uttarakhand, Arunachal Pradesh in northeast, there is a huge scope for small hydropower. Now we will discuss about solar energy, the most abundant energy found on earth. Why solar energy? Because the most obvious reason is that solar energy is the most readily available source of energy on earth. Then it is absolutely free. It is also the most important of the non-constrained source of energy because it is non-polluting. Earth receives abundant source of this energy from sun, and India alone receives solar energy equivalent to 5,000 trillion kilowatt hour per year. Only thing is that we have to start devise manners to utilize this energy. Solar energy can again be classified as two types. It is passive solar and active solar. Now what do we mean by passive solar and active solar? Passive solar energy is making direct and indirect use of thermal energies from the sun. Like a southern exposure of a building guarantees the maximum exposure of the sun's rays, and special metal leaf covering over windows and roofs can block out the sun during the summer months. So these are an example of passive solar energy uses. Active solar energy is the use of the sun's electromagnetic radiation in generating electrical energy. This active solar energy can further be divided into two forms, that is solar thermal and solar photovoltaic. Solar thermal is used for heating applications and solar photovoltaic is used for electricity generation. Solar thermal. Solar thermal is employed for collecting and converting the sun's energy to heat energy for applications such as water and air heating, cooking and drying, steam generation, distillation, etc. Basically, a solar thermal device is nothing but an absorber of sun's heat energy, a heating or heat transferring medium, and a heat storage or heat tank. So what is happening is that when the transferring medium is getting heated by sun's energy and we are utilizing that heat. Solar thermal technology employs an elaborate use of a black body because black body is absorbs the heat and good heat. It is a good heat conducting material, insulation and reflectors. Solar geyser, solar concentrator, solar cookers, solar still are some of the examples of devices which are based on this solar thermal technology. Solar photovoltaic. Solar photovoltaic technology is employed for directly converting solar energy to electrical energy by using solar silicon cell. Now it is commonly known as SPV, solar photovoltaic. Solar photovoltaic has found wide application in rural areas for various important activities besides rural home lighting. Remote villages deprived of grid power can be easily powered using the solar photovoltaic technology, and it can thus revolutionize the concept of making available the power in remote and far-flung rural areas. The economics of rural electrification can be attractive considering the high cost of power transmission and erratic power supply in rural areas. How electricity is generated through solar energy? Uh, Now we will see this, that solar photovoltaic can be used to generate electricity from the sun. So what is happening is that we are using a silicon solar cell which is made of silicon. It plays an important role in generation of electricity. A solar cell is nothing but a PN junction, positive and negative PN junction. As you can see from this clip, a movie clip, it will explain the concept of how the electrical energy is being generated by solar energy.
Sunlight is made up of tiny packets of energy called photons. Every minute, enough of this energy reaches the Earth to meet the world's energy demand for a whole year. Photovoltaic panels consist of many solar cells. These are made of materials like silicon, one of the most common elements on Earth. The individual cell is designed with a positive and a negative layer to create an electric field, just like in a battery. As photons are absorbed in the cell, their energy causes electrons to become free. The electrons move toward the bottom of the cell and exit through the connecting wire. This flow of electrons is what we call electricity. By combining solar cells and photovoltaic panels, we can produce just the right amount of electricity to perform a specific job, no matter how large or small.
This map shows the solar power projects map in India. It shows location where major solar power projects are being implemented or have been commissioned. Now we will come to biomass. Biomass power is the most relevant form of energy as far as rural areas are concerned, and it is the most important source of energy for production supplied by agriculture. This energy is also available in the form of biodegradable waste, which is the rejected component of available biomass. Organic matter in which the energy of sunlight is stored in chemical bonds. And when the bonds between carbon, hydrogen and oxygen molecules are broken by digestion, combustion or decomposition, these substances releases stored energy. There are again various classifications of biomass. One is biomass grown, that is plantation. The other is agricultural waste, waste from agriculture like straw, husks. Then there is animal waste, for example, cow dung. Then industrial waste like bagasse, dry waste. And the last is municipal waste, that is garbage and night soil. Biomass is currently the world's fourth largest energy source. India produces around 540 million tons of crop and plantation residues every year. Higher capacity factor. These biomass plants have got higher capacity factors than other renewables. And atmospheric gasification with dual fuel engine occurs. 500 kilowatt gasifier is the largest installation in this field now, as on date. Bagasse based cogeneration is another aspect of biomass power. What is bagasse? Bagasse is nothing but the residue left when the juice of sugarcane is extracted. So this byproduct of sugarcane extracted juice, that is bagasse, is used for generating power. First of all, this dried up mass is used in boilers to generate steam, and that steam is used in the process industry like sugar industry, and the surplus steam is used for raising the power. So it is a very important concept for a sugar producing state like India, and a lot of states, in lot of states, this sugar industry is already commissioned this bagasse based cogeneration plants. Thereby they are meeting their own power requirements, and the surplus power is being fed to the central grid. This table shows the state-wise potential of bagasse-based cogeneration plants. As you can see, states like Maharashtra, Uttar Pradesh, which are leading producers of sugar, a lot of potential exists in these states. And as far as total potential is concerned, it is around pegged at 5,000 megawatts. This is a plate showing a typical bagasse cogeneration power plant in Tamil Nadu. Now we will discuss about biofuels. What are biofuels? Biofuels are renewable fuels from biosources. They include ethanol, biodiesel and biogas. A lot of talk is being generated on biofuels nowadays, and why should we be using biofuels? Because by using biofuels, there is reduction of greenhouse gas emission. Then there is a security of assured supplies. Supply is also assured. Biodiesel is very environmental friendly, and it is a renewable fuel. No engine modification is required, and it is non-toxic, and it is easy to handle and store as compared to other conventional gas. In India, most of the trials were done using biodiesel from Jatropha and Pongamia. Other than Jatropha and Pongamia, the raw material used for biodiesel production are sunflower, soybean, rapeseed, and palm oil. In 2002, Indian Railways also conducted a successful trial run of an express using this biodiesel, and passenger train on the Delhi-Amritsar route is using 5% of biodiesel as fuel. Indian Oil Corporation has also begun this field trials of running buses on diesel doped with 5% biodiesel. All these examples show the increasing use of biodiesel in our country. Now we will discuss in brief about geothermal energy. Geothermal energy, as the name suggests, it is the heat from the earth. Geo means earth, thermal is heat. Heat from the earth. This heat can be drawn from several sources like hot water or stream reservoirs deep in the earth that are accessed by drilling. Then geothermal reservoirs located near the earth's surface, and the shallow ground near the earth's surface that maintains a relatively constant temperature of 50 to 60 degrees Fahrenheit. This plate shows a typical geothermal reservoir where the rainwater is seeping down below, and the hot rock which are already there, it heats underground water, and that water comes on surface in the form of geysers. This is a map showing hottest known geothermal regions in the world. These red regions exhibit the regions where geothermal activity is found. This is a map pertaining to India. This map shows the geothermal potential in India. This is an artistic view of how a geothermal power plant works. From this figure, you can see that there is a production well and there is an injection well. So wherever these geothermal activities are found and where it is established that hot water is available, that water is drawn from by drilling a well. That water is used for raising steam, and the steam in turn is used for generating power, and that same water is again injected back so that there is non-consumptive use of water. Now we'll see we'll discuss about tidal energy. Tidal energy traditionally involves erecting a dam across the opening to a tidal basin. This dam includes a sluice that is open to allow the tide to flow into the basin. The sluice is then closed, and as the sea level drops, traditional hydropower technologies can be used to generate electricity from the elevated water in the basin. Tidal range may vary over a wide range, that is 4.5 to 12.5 meter, and it depends on site to site. A tidal range of at least 7 meters is required for economical operation and for sufficient head of water for the turbines. Tidal energy schemes are characterized by low capacity factors, usually in the range of 20 to 35%, and there is a high capital cost for a tidal energy project with possibly a 10-year construction period. Tidal power generation may change the sedimentation and erosion patterns in the estuary also, and this is an added disadvantage. And pollutants discharged from the rivers upstream from the barrages may accumulate in the estuary. So these things have to be taken into consideration while designing a tidal power project. Now, other emerging developments in renewable technologies, we will briefly glance through this emerging developments. This is ocean energy. Ocean energy draws on the energy of ocean waves, tides, or on the thermal energy stored in the ocean. The ocean contains of two types of energy, that is thermal energy from the sun's heat and mechanical energy from the tides and waves. Oceans cover more than 70% of Earth's surface and making the world's largest solar collectors. The sun warms the surface of water a lot more than the deep ocean water, and this temperature difference stores thermal energy. Thermal energy is used for many applications including electricity generation. Ocean mechanical energy. In this form of scheme, a barrage, that is dam, is typically used to convert tidal energy into electricity by forcing the water through turbines. For wave energy conversion, there are three basic systems: channel systems that funnel the waves into reservoirs, float systems that drive hydraulic pumps, and oscillating water column systems that uses the waves to compress air within a container. This is an exhibit showing a wave energy plant. These waves are driving these turbines which are generating power. Now we will compare, we have so far discussed various forms of renewable energies. Now we will compare the capital cost and cost of generation of these various sources of renewable energy, also the conventional sources of energy. You can see from this table that typically a coal thermal power plant, the capital cost for establishing a coal thermal power plant is around 5 to 6.5 crore per megawatt. As compared to this thermal power plant, other sources of renewable energies are also indicated here. It can be seen that solar thermal power plants are still very costly. As far as capital costs are concerned, it is still not viable. The value ranges typically from 20 to 30 crore rupees per megawatt, and solar photovoltaic is still costly. It ranges from rupees 30 to 40 crores per megawatt, whereas small hydro is very much comparable with the contemporary power plants, thermal coal power plants, and it is in the range of rupees 4 to 6 crore per megawatt. Wind is also comparable to this small hydro. Now, as far as cost of generation is concerned, the cost of generation of solar photovoltaic energy is highest. It runs in the range of 15 to 20 per kilowatt hour, that's per unit. Whereas wind and small hydro are quite cheap. Now we will conclude this session. You see that India has competitive strengths in wind energy, solar energy, and biofuels. These are the three areas which we should concentrate upon to maximize the potential from these three sources of renewable energy, that is wind energy, solar energy, and biofuels. India also has an advantage because it has urgent needs, and to minimize the gap between requirement and availability of power, we need to rapidly search for alternative energy, viable energy sources. So these factors create conditions for India to move ahead. The government cannot do everything, however, individual or cooperative efforts can do a lot. Many rural communities consume little electricity, and extending electricity grids to meet their energy needs will prove more costly and take longer than harnessing new and alternative sources of energy already available in these communities, like wind, solar, and biomass. The attraction of these sources lies primarily in their abundance and ready access. The renewable energy technologies for exploiting these sources include biogas plants. So these are all these areas are very much relevant and very useful, may prove very useful for providing energy security for our rural areas. For example, biogas plants, solar lanterns, solar home lighting systems, then improved cooking stoves, improved lanterns, so particularly solar water pumping systems for irrigation, solar water heating systems, and water mills. These technologies can be readily used in rural areas for maximum utilization. So we have seen that by using these renewable energy options, we can have all these advantages, like it provides better lighting. Better lighting enables the poor to stretch their period of economic activity. The children can help them in daily chores and then study in the evenings. And it is very environment friendly. Efficient use of conventional sources of energy or use of renewable energy helps save the environment from further degradation and gives it an opportunity to regenerate. It provides these RETs provides sustainable fuel systems. For example, afforestation and agroforestry combined with the introduction of energy efficient devices can help to create a sustainable fuel use system within the rural community. This major advantage of using renewable energies is to the women. By using there is a lower dependency on fuel wood and other household fuel sources, reduces the drudgery of women by shortening or eliminating the distances they travel for fuel collection. The improved cooking stove, for example, has been associated with an average net annual saving of 7% of labor a year in India. These technologies also benefit human health. Use of improved cooking stoves and biogas plants, for example, helps reduce or eliminate health problems associated with using conventional cooking stoves and chulhas. Uh, then these enhance income also. Alternative energy sources can provide local employment opportunities through direct use of energy in small scale industry and agriculture. Now we will just take a brief recap of whatever we have learnt in this session. We have seen the how Indian power sector scenario is, and what is our installed capacity and what is our requirement, and we have seen that there is a huge gap between this demand and supply, and it is going to this gap is going to increase day by day. Then we have discussed about the types of energy sources, that is non-renewable and renewable. Non-renewable includes the conventional thermal power plants, nuclear power plants, and renewable energy sources are solar energy, wind energy, tidal energy, geothermal energy, all these biomass energy. These are all forms of renewable energy. We have also seen the benefits of using renewable energy sources and potential of renewable energy sources. We have discussed various forms of renewable energy in details, like wind energy, small hydropower, solar energy, biomass power, biofuel, geothermal energy, tidal energy, and wave energy. Of all these types of renewable energy sources, Wind energy, small hydropower, solar and biomass are the most relevant to Indian rural sector.
In most river basins in the Indian Himalaya, firewood availability is so poor that it is viewed as a crisis by the communities. Women and children have to trudge for 4 to 5 hours foraging for scarce firewood, basically for cooking.
हमको 4 या 5 घंटे तक एक गट्ठा लकड़ी में लगी जाता है, वो भी चोरी करके लानी पड़ती है, जंगल बंद हैं और कभी 4 घंटे भी लग जाते हैं, 5 भी लग जाते हैं, कभी हम लकड़ी नहीं मिला पाते हैं.
In a situation where the people's daily firewood requirement outstrips the annual incremental biomass growth in the forest areas, the only logical solution seems to be the provision of an alternate source of energy. Over the past 15 years, grassroots has been able to demonstrate the viability of an alternative by construction of household-level biogas units as a renewable energy option. These provide clean, smokeless cooking gas and thereby have a positive impact on the family health, besides reducing the biotic pressure on the forest resources. Depletion of forest cover also has an adverse effect on the recharge of the subsurface groundwater, which in turn leads to drying up of natural springs in the region. This means that women and children need to spend even more time and energy fetching water from distant sources. Fossil-based fuels like LPG, kerosene and coal are non-renewable and expensive. A large amount is spent by the government annually in subsidy and transportation of such fuels.
ऐसे वो महंगा पड़ता है, 310 रुपये उसके भराई हुई और लाने पहुंचाने में, और इसकी वो परेशानी अलग हुई. अब इसको एक बार बना लिया तो सुविधा हो जाती है.
Biogas is a renewable source of energy that is both ecologically sustainable and financially viable for rural mountain communities as well as elsewhere in the country. A functioning Deenbandhu biogas plant looks like this. Cow dung and water are mixed in equal proportion in the mixing tank and fed into the digester via the inlet pipe. The level of the mixture is such that the area inside is completely sealed and air is not allowed to enter into the mix. In the absence of oxygen, certain bacteria found in cow dung break down this mixture to produce methane, which rises to the top of the dome and is piped to the kitchen to be used as fuel. This cycle is continuous and a fresh mixture is introduced every day. When gas is formed in the dome, it increases the pressure inside. The increased pressure pushes down the mixture, causing the level of spent mixture to rise in the outlet tank, from where it moves out in the form of slurry. This slurry is mixed with dried leaves, leftover fodder and stalks to produce excellent organic manure. In colder climates, like the lower reaches of the Himalaya, the Deenbandhu fixed dome model is ideal because the digestion chamber is underground, providing good insulation against the cold. We use a design optimized for a longer 55-day cycle so that the mixture gets more time for digestion. Care is also taken to choose sites that receive at least 2 to 3 hours of sunlight in winter. We have found that while the production of gas does reduce by about 25% during 3 months in winter, the plants function very well, and a 1 cubic meter plant provides 3 to 4 hours of clean cooking fuel every day.
गैस में तो जल्दी खाना बन जाता है, आधे घंटे में चावल और दाल हाल सब बन जाती है आधे घंटे में, और चूल्हे में टाइम लगता है, फिर धुआं भी लगता है.
तो बहुत फायदा है. क्यों? जब हम खेती से आते हैं, खेत गोड़ने चाहे गुलाई करते क्या करते हैं, वहाँ आके एकदम से चाय बनाती हूँ और बच्चे कभी भूख लगी कहते हैं, अभी 1-2 रोटी बनाना है, उसमें बना लेती हूँ।
In order to expand the use of such appropriate technology applications in the Himalaya, we trained young men from local communities to construct and maintain these plants. This has grown to become a dedicated body called the Kumaon Artisans Guild, with over 50 barefoot engineers. The guild has so far constructed 1,400 household-level biogas plants in 8 districts of Uttarakhand and Himachal Pradesh, enabling these families to reduce their dependence on firewood or other fossil fuels for cooking. We have found that the critical factors for success with biogas are ensuring quality during construction and training user groups in the correct use and maintenance of their plants. Ignoring these critical issues often leads to the failure of biogas plants, perpetuating the myth that biogas technology is inappropriate in the Himalaya and elsewhere in the country. The main advantages of using biogas are: methane, one of the greenhouse gases responsible for global warming, gets burned. Households using biogas need very little firewood, reducing the pressure on our fragile forests. It reduces the drudgery of collecting and carrying firewood daily for women, freeing up time for other activities. It is smokeless and thus has a positive impact on family health. There are no recurring costs. The cow dung used is not lost, as the composted slurry makes a much richer organic manure. The challenge is to scale up the adoption of this technology to help protect the existing forest cover and allow revegetation efforts to succeed. A 1 cubic meter plant currently costs 15,000 rupees in hilly areas. With per capita income of mountain communities being low, the initial cost becomes a major obstacle in the spread of this technology. Households usually contribute about 70% of the cost in cash plus labor inputs. Grassroots has been providing the rest through a small government subsidy and donations from civil society. At a time when the whole world is waking up to the realities of climate change due to burning fossil fuels, and there is talk of carbon credits for the reduction of greenhouse gases, we must look at biogas with renewed interest if we are serious about providing clean domestic energy as part of our Millennium Development Goals.